Hello, this is eSpin Adam. We're happy to assist you with the upcoming presentation. Let us know if you need any help, and we'll be glad to be of service. Serverless computing mastering. Architecture, benefits. Use cases and best practices for cloud-native development. Here are the key takeaways from this topics. Serverless computing allows developers to build and run applications. How serverless computing works. Serverless computing eliminates the need for developers to manage this infrastructure. By allowing them to deploy their code in small, discrete functions or as part of predefined applications. Serverless computing operates on a function-as-a-service (FaaS) model, where developers write code that is executed in response to specific events like HTTP requests, database changes, or IoT triggers. Core components of serverless architecture. Several key components are functions, events, execution environment, automatic scaling, and pay-per-use. Applications are broken into smaller, independent pieces of code called functions. Each function performs a specific task and is triggered by an event like an API call or a database change. Events are the triggers that invoke serverless functions. Execution environment. The cloud provider manages the environment in which functions run. Automatic scaling. Serverless platforms automatically scale the application based on the number of incoming requests. Pay-per-use. It follows a pay-as-you-go pricing model. Users are billed based on the number of function executions and the compute time used, rather than paying for pre-allocated server capacity. Key benefits of serverless computing. Improved agility. Enhances agility by allowing teams to deploy individual functions independently. Cost efficiency. Serverless computing employs a pay-per-execution model. Users are billed only for the compute resources consumed during function execution. Automatic scaling. Scaling is automatic and handled by the cloud provider. This ability is especially useful for applications with unpredictable or spiky traffic patterns. Reduced operational complexity. Serverless computing removes these concerns by offloading all infrastructure management tasks to the cloud provider, allowing developers to focus purely on writing code. Faster time to market. Developers can build and deploy applications much faster. Developers can iterate rapidly, speeding up the process of delivering new features and updates. Use cases. IoT applications. The Internet of Things can be triggered by IoT events, enabling real-time data processing without the need for extensive infrastructure management. Real-time file processing. Serverless function could be triggered to generate thumbnails or compress the image automatically. Chatbots and voice assistants, triggered by user input such as a voice command or chat message, with the cloud platform handling the scaling and execution of the response logic. Data processing, triggered automatically when new data is available, eliminating the need to constantly run servers that might be idle most of the time. API backends. Serverless functions can handle HTTP requests and process them on demand. Serverless platforms and providers. AWS Lambda. IT allows developers to run code in response to events and automatically scales to meet demand. Google Cloud Functions. It enables developers to run code in response to events, automatically scaling the infrastructure as needed. Microsoft Azure Functions. It designed to integrate seamlessly with the broader Azure cloud ecosystem. IBM Cloud Functions. It supports the execution of code in response to events, with built-in scaling and integration. Alibaba Function Compute. It is used for applications ranging from web backends to IoT data processing and real-time media transcoding. Challenges. Cold starts. When a serverless function is called after a period of inactivity, the cloud provider must spin up the environment to execute the function. Vendor lock-in. Each platform has its unique API, configuration, and pricing model, which can lead to vendor lock-in. Debugging and monitoring. Developers need to rely on the cloud provider's built-in monitoring tools, which may not offer the same level of visibility as full-stack monitoring tools in a traditional server environment. Best practices. Optimize for cold starts. Developers should keep function sizes small. Breaking applications into smaller, more focused functions can improve performance. While use warm-up techniques, allow developers to keep functions warm by periodically invoking them to prevent cold starts. Focus on modular architecture. This modular approach enables easier debugging, testing, and deployment. Monitor and log effectively. Use centralized logging. Ensure that all function logs are aggregated in a central location to facilitate debugging and monitoring. Set up alerts. Establish automated alerts to notify teams of performance issues or failures in real time. Optimize function execution time. Leveraging efficient algorithms, optimize code for speed and efficiency. Managing dependencies, reduce the number of external dependencies to lower execution overhead. Implementing caching, use caching mechanisms to store frequently accessed data and avoid repeated expensive operations. The future of serverless computing. Increased adoption of multi-cloud serverless. Allow developers to deploy serverless functions across multiple cloud providers, increase flexibility, and reduce dependence on a single vendor. Expansion of serverless into edge computing. Achieve lower latency and higher efficiency, particularly for applications requiring real-time processing. Serverless databases and storage solutions. Provide on-demand scalability and pay-as-you-go pricing without requiring users to manage the underlying infrastructure. Improve development tooling and ecosystem. Provide developers with more control, better monitoring, and simplified deployment processes. Thank you for watching our presentation. We hope it was valuable and informative. For questions, contact us at info@espincorp.com or visit our website. Thank you again and have a great day.